sustainability and doing things right. So that's been my takeaway this week. And I think the things I've seen and heard from others lead me to believe that this educational workshop today and through the week and conversations that we continue on will be enhanced by our continuing communication and discussions about produced water management. And today I'm going to talk a little bit about really some best practices that really not going into a high level viewpoint locally, because I do think there's some great lessons learned when we take a higher evolution stance at what others are doing, because in many cases the things that don't work are just as important, maybe more important than the things that do work well. And hopefully we can share some of those
displays
as well. Hopefully the PowerPoint is going to work really good.
Just remove it. Remove it. Remove it. Remove it. Remove it. Remove it first now.
So this presentation is a collection of
this system never good. The system never good.
Intensive research and development over the last 3 to 5 years with over 1,300 IOCs.
Let's go like this. This is, I don't know where they say
countries. The numbers that might go up were not easy to collect, and there's still
why is it not displaying now?
Some of the numbers, and there's wide ranges in places like Permian and Delaware, in Texas and New Mexico and the U.S. There's still a lot of debate within companies that, because of the different hats I think that I've this week here in Trinidad and from Africa. That was before. I think these are all very interesting perspectives that we can share. But with going back to the U.S., looking at the amount of operators that we have.
Change it back.
It's changed quite a bit post-COVID, but in the U.S. alone, we have over 60,000 operators.
I said quickly change, help me, let me do something. Just sure.
Bigger companies,
you want to switch to instead of
yes.
This system will be explained. Should you understand? If you explain, I'm not going to get this issue. Say I do something with this issue. But you explain. That explain you know reflect. So I'm projecting directly to take up EPS again. So I'm doing different things at the same time. I'm doing projection to this. Projection last time is now for EPS. I didn't extend. Yes, I didn't extend it. I'll just move to OPS and do everything on OPS. But it's not like that.
To take the system to hospital where they work on the
They're working on it.
So we're involved in those operations. And then we have other telltale signs like the $4 trillion US dollars in Atlanta profits last year. That looking at sorry, that was 161 billion, 4.4 trillion in the overall global network. So we get a rough that 4.4 profits, but that was not the case. But 171 billion is there's been other NICs as well that have made some interesting statements recently in these past years or so. Petrobras has made a statement, and it was very clear last month, it's still this month. We had kind of a very January month, just for us for the presentation, we'll talk about there are 31 upcoming FPSO and offshore projects in the year ahead. Probably will be 12 months, but we know in the near future. So it's very clear that there are countries that are there's some similarities with production, where we go back and draw on time. It's very clear that the business like oil and gas and produce water is not going away. If we look at the recycling of that's increasing. We're not involved too much on that today. Overall water volumes, how the president emphasis for the 4 Rs that I've been using for a while now. And talk a little bit about just takeaways for what we can do better and how we can share information and lessons learned.
Projection. Projection number.
So looking at the volume of this water, we are looking at about 210 million barrels per year. So there's some that are being flat oil production volume in the year ahead that we could contribute to from 310 to 340 billion barrels. There are a lot of fields that are maturing, and the volumes increase dramatically. A lot of the early members, like the early members, they're going to pay because they show up late, specifically in Mexico, where it was very low water volume of water cut. That's changing. So where is it going? I think Saudi Arabia or Nigeria in the past, the volumes are one side of the oil balance rapidly changing behind this more water and oil. But one of the things that I really want to focus on is water should be looked at as a resource. It was not that long ago that we looked at gas as a byproduct of a problem for oil production, and we simply let it off. I believe that water will become something similar or maybe even more resourceful as a valuable commodity and traded as such. Much like gas is today. And firstly, what we need to do is change our mindset in how we look at and view water. And not as a problem or a cost or something just to deal with, but really how we can use it for production and how we can use it for better utilization as a resource, and also what we can do to help our bottom line. There's a long list of possibilities there. We touched a little bit on with mineral recovery, with lithium and other minerals that can be of interest, but just simply for purpose. Using water for frac flowback in the U.S. or in Saudi or in Argentina. Those are all possibilities where, yes, the capex is going to be quite high in the next few years with a higher range of spending. But initially, after the first 5 to 10 years, your cost per barrel will dramatically drop. And if you scale up, and if you have the volumes, which in the prices, the volumes are there, it is a great way to look at making more affordable as well. So a lot of what we've seen and had problems with in the U.S. specifically is the use of, not use of the water again. Quite frankly, it was less expensive to dispose of this water and just buy fresh water, groundwater, drinking water. So that was, still is for most a reality. I think that's slowly changing. One of the things that we're seeing water scarce areas, like the parts of Nigeria, Middle East, actually a lot of places that supply you that are having water issues, especially the clean drinking water issues. If we think a little bit more holistically, the life cycle of the water matches, slice and produce water, it makes a lot more sense to embrace the concept that we want to talk about during the 4 Rs. So simply looking at effective as possible. There's been a couple companies that are really well with this. And a lot of technologies, whether it's from the landfill or of course all the drilling companies, have done a great job keeping the water in the ground, not wasting it. The next are looking at recycling. So this is an area where most companies are doing an okay job or a good job, depending on where you are. Some are not. A lot of that goes back to my point about the typical purpose use for factory packaging. This is like the U.S. There's tremendous advantages for recycling and using that water. But currently there's a lot of examples of so much on volume recycled. There are areas where, again, because of transportation costs or infrastructure in place, makes it more affordable to look at other options for recycling. And the next bigger area that seems to be a hot topic, especially in the more and more in the U.S., a lot of talk about reuse and using beneficial reuse specifically for non-oil and gas applications. And they're quite a few. One of the roundtable several years ago, a few years ago, in Texas, where we talked about real life examples where this group of people had, within an hour, came up with 31,000 pieces of what they already used water for non-oil and gas applications. And I think if you look at what's already been done, it takes a lot of the mystery away from can we do this as a possibility. We've got real life examples whether that's in California with Chevron in the Kern River or in UAE, specific companies that are online with the application. Looking at a wide range of non-food product agricultural applications in other resources is a great way to make it more beneficial. To make it more economical, to come up with a solution for what to do with all this water. Because quite frankly, a lot of places in the world are drowning in water, in abundance of water. The trick is having the right amount of water when you need it and the right quality of the water. So again, a lot of people go into that. And then the fourth R is really looking at reassessing. Because things will change, they should change, and they do change. And without that fourth R, goes back to having that discussion, we are really missing out on the opportunity to improve and to engage with different teams. So just a couple of examples here for reduce. I kind of talked through this. Slides catch up. Yes. Very slow. Okay. Talked a little bit about this, but looking at keeping water in the ground, obvious. But one of the R's that I usually want to talk about, and a lot of the reasons for this is because if you're a water person, you're probably not involved with that group. And again, this goes back to what is like here in a couple of slides talking about the need for connecting the different groups that don't usually talk to each other within companies. Like this was, the build slide is super small for some reason. So, bear with me on the next one. So looking at recycling in general, a lot of this really go offshore, looking into hot port for whatever reason. or if you're onshore, if you're in unconventional production, these are areas uh, where you should be looking at recycling as standard, looking at what sort of water quality, what you need for formation. That's a wide range. It varies between company, through country, through fields. It's really not one size fits all. I think the speaker talking a little bit about that maybe is out in specifically for Nigeria. And then the third R is an area where lately we've been going to talk about how we use water for beneficial needs for applications, which is also very interesting. It's a great way to extract, reuse, and recycle, and find another purpose for water. But also, I feel really more excited about just the simple reuse of purpose because there's huge advancements that we can make. We talked about this question, especially during the afternoon that talked about how do we do it the right way, how do we not make mistakes, how do we put systems in place. Innovation is great, and innovation is here, but really you already have the technologies to be able to do pretty much anything you want. And a lot of it is utilizing it correctly, sizing it correctly, able to the right spot, the right location of the process. Those are the sort of things that should be looked at. I'm going to try to speed up a bit because I'm going to be out in 2 minutes. Looking at the different teams and how the 4 R's take a role in making decisions. Looking at how the different teams within a company operate. There are companies that have a water team. There are companies that have multiple water companies teams within different countries. And it's interesting to see the dynamics there. I think one of the takeaways also from this is really collaboration. And not only is within a company within my country, also specifically looking at Africa, we definitely can learn a lot from others. And I don't have the demographics quite yet from this event. I'm guessing that it's just as diverse as any of our other where you have more than just a few countries leading the discussion, and we've seen a few on stage. So some of the takeaways, let's say on that. Probably the first one for me is the reassessment of art. Really looking at the next one. Looking at the reassessment, we don't want to forget to go back and retrace our steps and make sure what did work and what didn't work. Again, the lessons learned usually, some of the best ones are if something didn't work, to share that. That's not a comfortable thing for most people because why do you want to talk about a failure? But if you don't share those sort of failures with your colleagues, the chances of them making those same mistakes are very high. And I've seen it time and time again, actually within one meeting within the same company, within the same day, going from meeting to meeting where they are simply just making the same mistakes over and over, without sharing with each other. So this is a great place to begin here in this workshop. It shows me that you're looking to learn and open to sharing that. And offering your advice and ask questions from others. conclusion slides here. I think what we need to really do is look at how we can operate for you, for your company, or for your team, an integrated visualization approach, strategy. And really, I'm sure you're saying, well, this is my job, and that's not. But again, building the interest, knowledge, and excitement about water. Because quite frankly, water in the past and reality currently, with the working for the gas company, it's not a water problem, although it really is. Nobody's excited about talking about water from the fossil fuels that's really focused on production from the oil and gas standpoint. If you can raise that, the excitement level with water, and use water and reverse the whole life cycle of water, I think you'll have a lot of people find that as you agree with you. Why they give clean money from their internal team. Next slide. So some of the things that in the future that we should be looking at is first and foremost we need to come up with something systematic and not just based on making as much money in this quarter as possible. Although that is a directive for a lot of folks I know. And I think there is a way to be profitable and do the right thing for the environment and also for our community. And looking at ways to employ best practices and lessons learned. I think focusing on besides environment safety is very key. I see time and time again people making best decisions because they're not thinking about the safety aspects of some of the around water, there's water, but it can also be potentially a lot of safety risk involved with that. So we need to take that into account as well. We need to look at solutions that are cost effective, maybe not initial capex, but also looking at OpEx and how that plays in. So if you can expand research and review from a quarterly annual basis that we go out a couple of years, I think that makes a lot more sense. We'll be able to make some better judgments and decisions based on that. And then what we can do better. Again, your peers, they really need monthly sharing. So I think that's the first thing to do. We can start with that and then encouraging others to do better. I think that's a great way to look at from a technical standpoint what is working, what's not working, from a industrial application standpoint, but in the industry, really raising the importance of water as a whole, and instead of just talking about it as an ESG and sustainability point, really making it part of the importance of what we're doing for as an energy company. And there's a few companies starting to do this. So I encourage everyone here to do it. Be possible, best possible water stewardship you can, because I think it's going to enhance what you're doing in the world. So just a few folks to thank on the next slide. Actually, wait till the attitude and messages to mention quite a few that we kind of share tons of data with me. Without that information and lessons learned, it would be impossible to come up and make those people about what others have done and how they feel about these sort of things. So, lots of folks know. Next slide, just go. Thank you. With my contact information. So, with that, I'm going to leave it for one or two questions. Let's take talking about development perspective. We moved on to the past level. What are some of the suggestions that you Great question. Well, I think we're always here and we want to do a wonderful thing because the attitude, the innovation, the ability to be flexible and to your interest to learn and share. And we'll hopefully see, not just listening from people here in the audience in this week, but I do think that a lot of like, as I continue my trip throughout Nigeria this week and next week, hopefully I'll see more of that. Whether it's in the field or in the boardroom or speaking to group of engineers. But I think the ability to use what others have done elsewhere, put a little bit of your own flavoring into that and adapt it for what makes the most sense for today. Because you have a lot of industry experts here, myself and my Continental solutions
the linear way. If you are managing produced water in a linear way, that means it is a cost stream. You are paying to dispose for it. You are paying as a waste. Now, what you can do is that instead of that, if you want to create a circular economy, if you want to turn produced water from waste to a commodity where you can generate value, then you have to start using the circular economy approach. That was one of the reasons one of the lady asked, like, why do we care about it? We can treat this produced water, and it can be used for energy expansion projects, such as using treated produced water to generate green hydrogen, which I heard about nitrogen. Nigeria is going very big on both the green and blue hydrogen, right? But Nigeria also has a very short on water. The per capita, according to Google, the per capita of water in Nigeria is 9 liters. Can anybody tell me what is the per capita of water for the United States? That means each person in Nigeria is using 9 liters of water per day in average. In the United States, we are using close to 350 liters of water. There's a huge difference because there's a huge water shortage. If you are using that fresh water to generate green hydrogen, that's not sustainable. We can treat this water and create green hydrogen. There is a big push for decarbonization, like direct air capture. The big IOCs are going into it. So you want to capture CO2 from the air so that you're using this decarbonization. You will need water to do that. You can use this treated water to decarbonize that. The data centers are growing. I told you about artificial intelligence and the need of energy. You will need a lot of water to cool the data centers. The data centers will be coming out here. You can use this treated water for the data centers. At the same time, at the right quality, you can use this water for irrigation, agriculture, or also aquifer recharge. I don't know any of the aquifer out here, but if your aquifers are depleting, your freshwater aquifer, you can treat produced water and compensate that. So produced water actually can be the new form of water if rightly treated. We have the right regulatory guidelines. That's why it's called fit for purpose. And that is the circular economy we are talking about. This is just to give you an example how we can turn produced water from a cost waste stream to a value-added stream and be part of the energy expansion. Next slide, please. Okay. Once again, I shared the water composition of the produced water out here, and in the United States is completely different. That was my question. So it looks like the TDS, total dissolved solid, in the produced water in Nigeria is about seawater level, a little bit higher than seawater level. All of us know that we use reverse osmosis, seawater desalination membrane to achieve fresh water, right? But if your TDS is really, really high, higher than 100,000 ppm TDS, 150, 200,000, you cannot use membrane technology to desalinate the water. The only technology that you can use during that time will be thermal desalination technology. Those are very expensive. And why it is hard to remove salt from water is because water is a very unique molecule. Its heat of vaporization is twice than anybody else. It's a very simple molecule. It's very hard to remove salt. That's why either you have to use a lot of heat or a lot of pressure. That costs money. And for a larger scale, whenever you are managing a lot of heat and pressure, you have to build a huge infrastructure. So in bad water technology, what we are doing is that I believe we are the only company in the world that can desalinate high salty water without using very minimal heat and very minimal pressure. Okay, next slide. This is just a brief overview of how the technology works. I'll be more than happy to talk in detail off-site, but we are using zero-valent iron in the form of nanomaterials. We'll be dropping out salts. It will be in the lattice-like structure. Once again, it's very cost-effective. It has not been proven in the field. We are in the early stage trying to design and build our first pilot unit. But overall, everything looks great. And one of the components that I mentioned in the end is mineral recovery. From that circular economy, and Dr. TJ also mentioned that when you are treating this produced water, you will be creating a concentrated brine. From that concentrated brine, you can recover high-value minerals like lithium, magnesium. Actually, that can also help into the electrification, also the EV industry, where we need a lot of minerals. So that can be obtained as well. Next slide. This is just one approach how we can use different technologies to treat produced water at different level and use for fit-for-purpose application. This is for our case study. We plan to treat produced water higher than 100,000 ppm TDS or higher, use the bad water alchemy technology. In the beginning, for the last final mile, we might use complementary technology to supplement that to get the water quality that we need for fit for purpose application. Next slide. This is just an introduction of our team, who we are, okay? If you can see, these are all PhDs. They're way smarter than me. So we know what we are doing, and that's what I meant to say. Next slide. Thank you. I'll be more than happy to answer any question. Yes, Ben.
Would love to hear a quick overview on how Badwater Alchemy approaches, obviously in different basins, different parts of the world. We're talking about fundamentally different water quality and things in the water, et cetera. How do you approach from a sort of a top-down level of, you talked about you're in the design phase of this first unit. How are you looking at deploying that, and sort of what are the specs there? And then if you're going to look at something, Permian versus Nigeria as an example, to bring the example I was talking about yesterday, how would you sort of modulate that process? And what are your thoughts in terms of the data that you need to make the informed decisions? I'd love to sort of get a top-down view of how you approach that problem.
Thank you, Ben. Let me give a little bit of background about Badwater. When Badwater Alchemy started, they started as a seawater desalination technology. None of the team knew anything about produced water first, because they were completely unaware that the startup is based in Seattle, which is the information technology hub. Our CEO, he used to work with Bill Gates for 8 years. So nobody knew about produced water. So they said, they published 2 papers in the Journal of Water, peer-reviewed paper, and then suddenly the operators in the United States start calling them. They came and attended the first Produced Water Society meeting in 2024, February. That is the first time they were exposed to the produced water. And then soon they realized, that's when I was introduced to them, and that's how I came back into the team. So soon they realized is that actually their technology has a higher value proposition in produced water than seawater desalination. Why? Produced water is a big issue in the United States. The cost of treating produced water for 1 barrel could range up to, or disposing, managing is around $2 per barrel. Now imagine if you are producing, if your oil to water ratio is 1:5, for 1 barrel of oil, you are generating 5 barrels of water. If it's $2 a barrel, it's costing you $10 to manage this water, right? If the price of the oil is high, that's fine. If the price of the oil starts going down, it certainly becomes an issue. And there is not any great technology that can take this high salt water and generate a very high quality freshwater quality. The only technologies that can do that are the thermal technologies or the modification of membrane technologies. Because the volume is so high, for beneficial reuse or for this desalination technology to make any dent in the industry, we have to treat produced water in million barrels per day. We need huge project. For that, you need huge capital. So billions of dollar in capital investment just to put a desalination. So nobody was willing to do that because the capital cost was high. Then we realized there is an opening for us because we can treat produced water at 1/10 of a cost of the thermal desalination technology. Our capital cost is 1/10 the cost of the thermal desalination technology. Our operating cost is also cheap. Once we saw that opening, we decided to target the produced water higher than 150,000 TDS water or higher only. Why? Because nobody else can be as effective, as cost effective as us. So that was our approach in the United States. Overseas, as I said, first we want to prove into the United States, and we need to understand the water quality, the need in the market, and the cost as well. So I'm out here in the exploratory phase. I'm trying to understand what quality of produced water we have, what kind of volume we have, what kind of challenges we have. Is there any benefit for treating this water with a technology like ours cost effectively? Is there any interest, right? One benefit I see is in solid management. What do you mean by that? Because the TDS of the water is not super high, our byproduct is solid waste. It will be easier for us to manage solid. That's a separate conversation. I hope I answered your question when I'm going on and on, so I'm going to stop. Anybody else has a question?
Yeah, thank you. My question is this. How can you, the relationship between produced water and decarbonization, I want you to buttress more. How do you use produced water to achieve decarbonization? Because this news of reduce greenhouse emission has been over and over and over. I want to know what is the relationship. What can this produced water do? How? And how efficient is it in using this to achieve decarbonization? Thank you.
Thank you. So I was mentioning about how treated produced water can be used for some of the energy expansion project, right? One is electrification going into EVs. EVs will need a lot of high-value rare earth minerals. Produced water has a lot of that. If we can abstract those minerals cost-effectively, we can supplement the EV industry. The next thing is that in terms of decarbonization alone, let's say DAC, they call it direct air capture. Exxon, Oxy, Occidental Petroleum, ExxonMobil, all of them are investing billions of dollars in putting together a DAC project, direct air capture project. You can do DAC with two ways. One is liquid waste or one is dry waste. If you're using liquid waste, such like Oxy, you'll need a lot of water. Let's say Occidental Petroleum is building their first direct air capture project in Texas. For that project alone, in one day, they would need 200,000 barrels of water, high quality water, right? So instead of using fresh water, you can treat this water and use for that. Also for hydrogen. Hydrogen is a low carbon energy, right? We can treat this water and use this treated water to generate green hydrogen. So produced water can actually play a lot of role. So the Nigerian oil and gas industry can actually leverage the oil and gas, leverage all the benefits of the oil and gas, and use produced water in all the energy expansion and decarbonization projects side by side. We have all the potentials. We just need to make sure that we are aware of it and working towards it. I believe there was a question out here, yeah.
Thank you for very insightful presentations. My questions has to do with how produced water can really enhance the potential of agricultural production in Nigeria, because one of the benefits of produced water has been identified to be in the area of agriculture. My concern is on the crop production, because we have huge deficits of irrigation infrastructure in Nigeria. I don't know, I want you to clearly give us an example of where presently in the world we have any country that is using produced water for agriculture, and has that actually impact on their productivity agriculturally, and how can we as Nigerians expect to boost the application of produced water to support our irrigation infrastructure?
Thank you. Now, full disclosure, I don't know much about the Nigerian agriculture industry and the water demand and everything, so I will answer your question as what we are doing in the United States. That might be an example, okay? So in the United States alone, it's the same, because Permian Basin that Ben and Steve and everybody was talking about, this is the West Texas, New Mexico, Texas. It's a very arid region. So water is a big issue out here, both in agriculture and irrigation. But treating produced water has been looked into one of the alternative source of water by treating produced water to see if we can use it in irrigation and agriculture purpose. But the challenge comes around what is the right quality water, right? What is the quality of the water needed? Of course, do we have the technology? Is it going to be cost effective? Those are all out there. So one is the right quality of the water, because what we don't want to do is that the public relation, oil and gas industry gets a very bad reputation, very bad name in terms of the environmental people. They think that the oil and gas industry does not care about the environment. We are the bad people ruining all the world, right? So if we use produced water and use for irrigation or agriculture or for crops, and let's say down the road something happened, there will be a big liability issue. For that reason, in the United States, there is a lot of study going on right now, treating produced water to different quality, and then first testing it on non-edible crops. Like, what are some of the native plants in Texas? What are some of the native plants in New Mexico? Can we grab the soil of some of those native plants and then run a test with the regular nearby aquifer water available versus different level of treated produced water? How does the crop grow, right? What is the mineral content intake into it, right? All of those studies are being done. Why? Just to make sure that the liability issue is addressed. But I feel confidently we have the technology to produce water to whatever quality of application we needed. The most important thing is that it needs to be top-bottom, means the regulatory bodies, the ministry level decisions, we need to have a good vision and plan to do that. Once that trickles down, we'll find the right technology, we'll come with the right standards, we'll also find the right plants and crops to start with. We'll have to take baby steps, but I 100% agree with you. This can be used to supplement that both irrigation water and agriculture water. Any other questions? I will be around the Produce Water Pavilion booth out here if you have any further questions, and my information is out there as well.
Okay, I just want to know, do you have a team? Do you have a team that has plans to give this awareness in Africa of produced water and its benefits? Do you have a team that you put together, or are you just coming to give us this and then go back to US and run away? Do you have a team whereby people that are interested in this, young people in Africa, can, research in this? I mean, I know it's not your responsibility as white people here, but do you have a team that, since you are here to bring this awareness to us, there are people here watching you, they are interested in this produced water, they want to go, they want to understand it deeper. Do you have a team that you have put in place to carry them along? Thank you.
Thank you for your question. What is your name again? Can you mention your name?
Samuel.
Samuel? Samuel, you are the new member of Produce Water in Nigeria now. So, Produce Water Society is a volunteer organization. My first introduction to Produce Water Society was around 2015. I attended just like attendees, right? And then what we do is that we try to find local individuals, students, young professionals, of course the thought leaders within the overall ecosystem who cares about water. Not only produce water, who cares about water, who cares about our environment, who cares about providing a clean air and clean water to our next generation, to our sons, daughters, and grandsons and granddaughters to come by. And then we find volunteers. We found Jeremiah Peter. He has volunteered to be part of the young professionals for the Nigeria. We are looking for volunteers because we are a volunteer association. The only way that we can share and spread this news and all our learnings experience from some of the folks that has been involved in the industry is that if you become part of it, without your involvement, we cannot do it. So welcome to the team.
And I'm going to echo a similar sentiment. I was going to wait until a little bit later in the day, but since we're talking about it, for anyone sitting out here, if you're interested in this topic, if you're wanting to be more engaged and learn more and be a part of the solution, we are actively looking for partnerships, looking for people to help us get the word out, have events, do things like this. And so if that is of interest, Ben Samuels, Steve Coffey, Raj Giemeyer. Easiest is probably to find us on LinkedIn. You can obviously get one of us face-to-face. We can exchange contact information. But if you want more information on how to get involved, we absolutely would open that, open arms and have that conversation and see where you can fit. We're going to go ahead and roll into the next speaker here. It's my pleasure to introduce Russell Hempsey, a seasoned professional with 30 years of experience in the oil and gas industry. Russell began his career with Schlumberger, which is now SLB, in 1995, working offshore on North Sea production platforms and drilling rigs before transitioning into the technical sales role at Aberdeen. In 2009, he took on an international assignment with Halliburton in the Congo, where he managed sales and product operations across sub-Saharan Africa. And he later joined Advanced Sensors in 2012, overseeing business development in Europe and Africa. Since 2019, Russell has been with Innovate Systems, driving business growth across both regions. And today, Russell will be sharing his expertise on process and discharge measurement of online oil in water for regulatory reporting in remote unmanned locations. With his deep energy and industry knowledge and global experience, he's well equipped to provide valuable insights into the critical topic. Please join me in welcoming Russell Hempsey.
Thanks, Ben. Makes me feel really old, 30 years in the industry. Thanks, everybody, and thanks to the organizers for putting this together. It's great to be back in Abuja. I think the last time we had a produced water event here was maybe 2019. Yeah, so it's good to be back. Hopefully it's not so long next time. So we can put the first slide up if it's ready, please. Okay, here we go. I'm going to talk about oil and water measurement as opposed to treatment, and explain a little bit about the background of our company. The research and development started in 2016, and we officially launched as a company in 2018. And introducing a brand new product to the oil industry is not easy. Everybody wants new technology, but nobody wants to be the first to try it. That's the conundrum we all face. However, we were successful, and after good initial first year, we moved to our new offices that you can see here. This is in Belfast in Northern Ireland. And our goal is to provide the best available technology for online oil and water analyzers. That's our aim. We've currently got over 600 analyzers in the field globally. We've got over 20 staff now, and we now have a strong vendor list, which makes it easier to convince customers that our technology is appropriate for them. Next slide, please. So these are the two main types of oil and water analyzer that we offer. On the left, you can see a probe system that goes directly into a pipeline or a tank. And on the right, there is a side stream setup that takes a bypass flow from a main process line. Next slide, please. So the technology used is called laser-induced fluorescence. You can see there is a light coming out of the measurement chamber here and out of the end of the probe here. This is a very well understood and well known measurement technique for oil and water. It can run for long periods of time, which makes it desirable for oil and gas installations. Nobody wants to be maintaining equipment frequently. And it works really well for measuring crude oil and water. And it can be a robust technique, but there are some drawbacks with it that we've had to develop our technology to overcome. Next slide, please. So these are some of the challenges you face with laser-induced fluorescence. You can experience interference from chemicals. All produced water contains chemicals, so you have to expect that it's going to be there and implement something within your technology that can deal with that phenomenon. You can have different oil types that will fluoresce in different ways. The optical window becomes fouled very quickly in produced water. It's quite a nasty environment for anything you want to keep clean. And other things occur like damaged measurement windows. The systems can overheat, particularly in places like Nigeria where the ambient temperature is pretty high. And the laser that is the basis of the measurement has got a finite lifespan, so you need to be able to manage the lifetime of the laser. So I'll talk a bit about some of what we've done to overcome these challenges. Next slide, please. So chemical interference, this can come from a lot of commonly found chemicals that are used to assist with the water treatment process, like corrosion inhibitor, demulsifiers, soaps. Things like these generally result in a false positive. So 15 ppm of oil in the water, and the analyzer could be reading 30, 50, or 100. So that's obviously not acceptable. And then some chemicals, such as glycol and methanol, are known to have a negative, a false negative, which means the analyzer is reading lower, which can be an even worse problem because you think the water is clean and it's actually got quite a high ppm content in it. So if we go to the next slide, I'll explain how we deal with that. So the important thing is that we use a spectrometer as our measurement device. So what happens is the laser is shone into the water, the oil molecules in the water fluoresce and give off light, and we use the spectrometer to measure that light and convert the light intensity into a ppm value. That's how it works. And most companies that do laser-induced fluorescence measure on a single wavelength. So for example, you can see here, we've got a spectrum of wavelength. They will measure on a single wavelength. And what you can see here, we can measure over a broad spectrum. And that means when you see spikes like this one here, that shouldn't be there. So we can move the measurement wavelength to the left or the right of that spike, thereby eliminating that chemical interference and providing accurate measurements. So that is a key aspect to our technology, is having that spectrometer to be able to measure accurately and repeatably. Next slide, please. So the window, the optical window that I showed you earlier, where the fouling or the laser shines through, this can become fouled very easily in produced water. There's a lot of, even the crude oil will stick to it. And what happens is, over time, you can see the ppm values on the left are responding up and down as they should be. That's a normal trend. And as the window becomes dirty, they slowly tail off towards zero. You lose any granularity or accuracy within the measurement, and very soon the analyzer is reading zero. So if we go to the next slide, and if you can make the video play, if that's possible. No, go back again. Is it a P? Try again, the next slide. Okay, it's not working, so if we go back. So this is the optical window here with the crude oil on it. To keep that clean, we use automated ultrasonic cleaning, and that activates periodically around about every 5 minutes, but can be adjusted depending on the process. So that basically cleans the window. If anybody's interested in seeing the video of how it actually works, please come and visit me on the stand straight after, and I'll explain and show you how it works. So that keeps the measurement window clean at all times. Next slide, please. So I mentioned overheating, particularly with hot processes and hot countries that you are commonly found. So what we do to overcome this is we use active internal cooling. So we have thermoelectric coolers, otherwise known as Peltier devices, on critical components, and we use these thermoelectric coolers to keep the internal componentry cool, so that there's no failure caused by high ambient temperature. One of the key developments we made was the laser has a finite lifespan. It lasts on average about 18 months, can last up to 2 years. But what you really need is something that when the laser fails, you've got a backup. And that's exactly what we've done. We've put in a backup laser into the analyzer. And in places where it can be hard to get to, which is a lot of the oil and gas locations around the world, this is an invaluable feature, because it means the laser, when it dies, you've got a backup that's activated immediately, and that gives you another 18 months in which to contact one of our service technicians to come out and replace the original laser, so you don't have any downtime associated with this laser lifespan. Next slide, please. Okay, so what I'm here to really talk about is an application in the North Sea where a client had installed technology to measure oil and water, because the platform was going to be unmanned in the near future, and they wanted a reliable online oil and water analyzer. So they couldn't find anything, so they contacted us in 2020. We provided the probe that you see here. It was initially commissioned remotely because of COVID, and this was successful. There was good correlation with the lab. However, they were having issues with sludge buildup in the line, and of course, it's an oil and water analyzer. It's not an oil and sludge analyzer. So we got on to Teams calls with them, looked at a better location, and they moved the analyzer to a new location. And if you go to the next slide. So yeah, the previous location was a horizontal pipe, and there were dead spots in it, which was allowing the sludge to build up, and that's where the probe was based, which is obviously not a good location for an oil and water analyzer. This is the new installation here. You can see the probe installed using a double block and bleed valve that allows the probe to be retracted under live process conditions with no leakage. So this was actually then commissioned by Innovate personnel. Our guys went offshore, they correlated the analyzer to the lab, and they were ready to start reporting the discharge using this method. Previously, they had used a lab method because that is the approved method in Norway, and in fact, it's the approved method in most countries around the world. However, because they were going unmanned, they could no longer use the lab, which is a manual process. That's why they wanted to use the probe. The authorities in Norway accepted the accuracy of the probe, and they allowed the operator to use the probe as the reporting device. So this is the first time in the world where an online oil and water analyzer has been used on an unmanned platform for overboard discharge reporting of oil and water values. And if you go to the next slide. So what we see here is they actually put in two analyzers because they needed redundancy in case there was an issue with one. So in blue, you can see the analyzer A. In orange, you can see analyzer B. And the gray curve is the lab method. And what you're looking at here is 15 months worth of data from July 2022 to October 2023. And the criteria that the Norwegian authority set was that the analyzer had to be plus or minus 4 ppm, and that they still had to take a weekly sample, but they no longer had to take daily samples. So you can see here that the analyzer has always read correctly according to the lab and according to each other analyzer. There were times here, like these spikes. This is where the analyzer was taken offline, or the actual line was no longer in use. So in general, the results were fantastic for a long period of time, which demonstrates that the analyzer is robust, is staying clean, and is not being impacted by chemicals or any of the other phenomenon that I explained about earlier. Next slide, please. So just as a caveat, you can install oil and water analyzers in a horizontal pipe, provided you take into consideration what's happening with the flow. Make sure there's a reasonable flow velocity. Generally above 0.5 meter a second is required. Ideally, it's above 1 meter per second. And if it is quite low, then install it like this one here, which is quite close to a bend, which makes it the oil and water is turbulent and well mixed, and it's not all the oil sitting at the top of the line because of low flow rates. So and basically talk to us before the installation. We get much better results when we're involved in where the analyzer can be placed in the pipeline or in the tank, because we've a lot of experience in doing this. Most of us have been doing this for 12, 15 years, so we've a lot of experience. Next slide, please. Is that the last slide? Yes, I think that's the last slide. So thank you, everybody, for listening. I appreciate your time. If you have any questions, feel free.
Thank you so much for this wonderful presentation. My name is Dr. Goodluck. I think I can identify with you because I worked sometime with Halliburton, so maybe after that I will see you. All right, I have two questions. The first one is, in terms of safety, are there any specific safety concerns or consideration or hazard associated with the analyzer? That's one. The second one is that how does the analyzer handle potential interference from other chemicals or contaminants? Thank you.
Thank you. Well, yes, there is a safety aspect because it's an electrical item. So we have to get safety approvals. We get type approval from a notified body, FM approvals, and it has to be certified for use in the specific zone that it's going to be used in. Does that answer the first question? Yeah. Oh. And the second question about chemical interference, that I did mention that when we use a spectrometer to overcome that chemical interference. So when you get chemicals in the water, they can fluoresce, as you probably know, and we use a spectrometer to filter out that fluorescence, and that's what allows the analyzer to remain accurate for long periods of time because it's not impacted by chemical interference.
Okay, thank you, Russell, for the presentation. I'm just wondering if the analyzer is giving the data in terms of TOC, or it could give TPH, PAH, benzenes, could it have in that? And then the second question is it ideal for, say, environmental monitoring, say on streams and what have you, water bodies, aside overboard disposals? Thank you.
Sure, thank you. Great questions. In terms of TPH or TOG, really the analyzer can be correlated to any lab method because that's how we set it up. You know, we can calibrate it, but it's never going to be accurate until it's correlated to the lab method. So whatever that lab method may be, it varies in different, you know, from country to country. Like you say, TPH, TOG, we can generally set it up to whatever that lab method is. And the second question in terms of environmental monitoring, it can be used for that, and they are used for that. However, the main caveat is you need to know the oil type. You know, it can't just go in and measure, you know, say there's the possibility of 100 different oil types. You need to have some idea of what oil is there so that you can calibrate it properly. Secondly, it needs to be in a light, tight environment, so no ambient light, because the ambient light can interfere with the measurement. So yes, it can, but there are some things to be understood.
How would you deploy it in an environmental situation with the ambient light and what have you? Would you have some kind of casing or something?
Yeah, we've actually, on the probe that you see there earlier, we've actually put a shroud around it to block out the ambient light. So we found that that has worked, you know, in open tanks and, you know, pools and ponds. So that's one of the things that we've done to prevent ambient light.
Can you hear me?
I can hear you, yeah.
During the analysis, after the analysis rather, how do you ensure data quality and integrity? And what strategies do you use? And what strategies do you use to ensure that this data that you generate, I assume you generate a lot of data, yeah? I'm concerned about that data. So how do you ensure the quality and integrity of that data? And what strategies do you use to address the potential biases in the data generated, please?
Yeah, thank you. The way we ensure that data is accurate and of good quality is by correlating it to the laboratory method. And the laboratory method is always seen as the gold standard. It doesn't necessarily mean it is the gold standard, but that's how the analyzer data is qualified. And if we don't believe that the lab data is accurate, you know, our guys that do the commissioning will actually point out, because they've all been trained in lab methods, so they can say, look, your lab method is not being followed correctly if we don't believe that the data is correct. But basically, we correlate with the lab to make sure that the analyzer is reading correctly. Thank you.
Thank you, Russell. Give me a round of applause. Excuse me.
We're going to go ahead and move on to the next presentation here. It's my pleasure to introduce Mr. Opade, a highly accomplished senior technical sales executive with over 9 years of experience in driving revenue growth and delivering innovative solutions. With a background in technical support and problem solving, he excels at bridging the gap between engineering experience and customer needs. Currently with Boaz Integrated Energy and Allied Services, Mr. Opade is dedicated to leveraging his R&D R&D knowledge, leadership skills, and collaborative approach to foster innovation and exceed customer expectations. We truly appreciate your time today. Welcome on stage. Thank you very much.
Yeah, thank you. All right, good afternoon, everyone, and thank you for having me here. All right, basically, I'll be representing Chief Westerby, who is unavoidably absent here. So I hope that I'll be able to do justice to this. So this afternoon, we'll be talking about the holistic optimization water treatment measurements that is needed. You know, just as other speakers have rightly said, you know, I believe that the issue of produced water management cannot be overemphasized. So, and there is need for us to actually, you know, put some measurement to it to, like what the previous speaker, you know, mentioned, talking about an analyzer. So what we have also is what can measure the oil in the water that is being produced. All right, let's have the next slide. All right, so talking about treatment of produced water, we believe that there are two categories of water treatment, you know, to remove oil. And, you know, one of it is gravity, and the other one is filtration-based system. And the examples of the gravity separators are, you know, that we use is free oil removal without chemicals. We have the flotation, then also we have the hydrocyclone and some other technologies like that, which will definitely remove the oil droplet from the water. You know, with the addition of chemicals, these technologies can also remove dissolved oils. Then also talking about the filtration technology, filtration technology is able to remove dissolved oils without chemicals. And the above gravity separators are needed to remove the oil droplet prior to filtration to reduce maintenance and operating cost of filtration technology. Okay? All right, so talking about the monitor process for, you know, our technology helps us to monitor the process, you know, before discharge. You know, the first one is that you'll be able to get monitoring before the treatment system will improve the whole process. When you're able to monitor the process of treatment of the water, and you get to understand what the particles that are present, you can use that information to, you know, to make some informed decision instead of just, you know, doing, you know, going about just offering some treatment that you may seem like. But when you have a monitor, oil in water monitor that can give you those information, it will help you to make those informed decisions. Then operators can improve the process before discharge, like I've mentioned. Then choosing the technology for monitoring is related to the treatment technology. So for a holistic view of how to optimize the water treatment system, the operators need to know if the water, the oil and the solid concentration that's, you know, that are present, they are stable upstream of the treatment system. You know, advanced warning of changes and offset can help operators to adjust the controls before the water is discharged from the treatment plant. All right, let's move, okay, the next slide. All right, so now we just quickly talk about, you know, sometimes talking about the dispersal, you know, when measuring oil in produced water process, the result will be defined by the method used. And each method has a slightly different sensitivity to the oil present, and understanding the method and its response is important. It's very, very important as it relates to produced water management. So free oil droplets and dispersed oil, you know, they are generally the same thing, and they means, you know, oil droplet that can freely flow to the surface by itself, and, you know, within time available in the tank or water treatment system.
While the other type, the soluble oils and emulsified oils, they are often combined in definitions. And these are type of oil, that does not float to the surface. However, soluble oils, are light sugar or salt in water. They fully, chemically contained in the water. Then also, an emulsion is generally a very small oil droplet that is slow to flow to the water surface. So basically, the soluble or emulsified oil, they are basically the ones that doesn't float naturally to the surface by themselves. One is dissolved in the water, while the other will gradually float to the surface. All right, let's move on. The next slide, please. All right, so this is a typical, picture of, I'm coming. So this is a typical picture of a disperser. So this is an example to what is typically considered free oil. So free oil is oil droplet that will float out of water. However, it is good to remember that oil can be stuck to rust, sand, or other surface. As you can see on that surface, these are free oil, but as you can see there, you can see that there are some dispersed oil that stick, to a particular surface there, which, can, probably at the point of, doing the water treatment, you may not be able to treat that at that time, but we have a technology that will help, to detect all. All right, so we just quickly go through the example of the conventional way that water is being, measured, to get the content of the oil in the water. The one is EPA 1664A. So this, what you do is collect 1 liter of water and add 100 milliliter of hexane, and extract the oil into hexane. Then you shake it. Then after that, after about, you can do this step in 3 phases. In 3 steps, you add the 100 milliliter of hexane to the water, shake the container for like 2 minutes. After that, then when it is settled, then you allow the hexane to evaporate. Then you collect all the 3 hexane samples, put them into a single container, then and let the hexane evaporate. Weigh the oil droplet after the hexane has fully, evaporated. That's the usual, the normal way that it is being done. Then it is worthy to know that this method is time-consuming, not sensitive to oil below 5 ppm, and has a very low sensitivity to light oils. Then light oils will evaporate easily, and they cannot be easily detected by this method that we've described. So when you have this kind of oil that is present in the water, you will not be able to, you will not be able to detect it using this particular method. All right, let's go to the other method. All right, we have the OSPA GC field method. Now, this one talks about, getting similar to that. You get a 1 liter of water, which is collected and acid is added to it. 100 milliliter of pentane is added to the extract oil. Now, once the pentane is collected, the solvent is analyzed by a gas chromatograph, and the concentration of oil from C7 to C40, that is the number of carbons that are present in it. So the result of the ethylene and benzene and acetylene are subtracted. So any heavily oil that is above C40 and light oil will significantly reduce response. Now, this type of method will not be able to, determine the heavy oil that is above C40. So he said this method also is very time-consuming and extremely difficult to measure, on offshore platforms. All right. So now let's go to the field analysis. Now, on field, instead of using the other 2 methods that we have mentioned, there are alternate methods that, that can be calibrated to produce similar results as the one that we have mentioned. So all field sample methods use a water collection and preparation process. Most use a solvent to prepare the sample as well. So, for example, UV fluorescence is a very common technology that is used. So here, all solvents can be used to prepare the sample. So once prepared, the sample can be analyzed in about 5 seconds. Then also we have the infrared type, which is also a common technology. There are 2 methods here. One cannot use a petroleum solvent, while the other can use. But the response of the one that cannot use a petroleum solvent is very fast, while the second method, using a petroleum solvent, requires all the solvent to be evaporated before the analysis. So it means you have to wait for the solvent to evaporate before you analyze. And here, this also can take 10 or more minutes for each sample that is taken to be analyzed. All right? All right, let's go to the next slide. So this is just talking about produced water sample. It's just showing the oil that is stuck to the cap. Then we have one that can be stuck to the glass, floating. Then we have the one that can float on water. Oil droplet dispersed in water, oil droplet associated with solids. Then also oil is present with water-soluble organics. So the reason that a solvent is needed to prepare a sample is because oil is very quickly sticky and will quickly float on water. And this is why we need a solvent here. So after collecting a water sample, the oil will quickly float or stick to the bottle walls and solids. So if a water sample is collected after this separation, it will not include, all the oil that was in the original sample. So you can see this method also, it cannot be trusted fully. All right. So we have let's look at the solvent. Let's go to the next slide, please. So typically, 1/10 of the water solvent that is added for the extraction can be adjusted as needed. So once a solvent is added, the bottle is shaken for 2 minutes. I've mentioned that before. Then we allow it to settle. Then the addition of an acid to the sample will help the solvent extract organic acid from the sample. So when the sample is settled, the operators will collect some of the solvent that are separated and analyze the solvent for oil. We can see the process, but the result is 10 times higher than the original water concentration. So the result is reduced to a ratio of 10 to 1. All right? So now we are looking at the no solvent extraction. We have looked at the solvent extraction method. Now let's look at the no solvent extraction oil in water analysis. So optionally, benchmark solutions now has a surfactant-based no solvent method to fully disperse oil in the water phase. After the preparation is completed, the water can be directly analyzed by a UV fluorescence analyzer. So we have an analyzer that can be used without using a solvent. We have a monitor that can be used to carry out this method without using a solvent. Okay? All right, now let's move to the next slide. So now we have some of our technology. We have like 3 to 4 technologies that we can use to do this analysis. The first one is UV fluorescence, and all 3 of our technologies can continuously run online. That is, for you to use it, you have to plug it to a sampling point, and you take its reading, and it continuously, take the reading, analyze it on its own. So for the UV fluorescence, it can get you the total oil measured. Then it can also get you, you can measure below 1 ppm through up to 5,000 ppm. Then there is no effect from solids, water chemistry, or salinity. This is a low maintenance design, no moving part, no chemicals, no reagents. That's one of our technology, and that's our TD4100. Then also we have the particle image analysis, rather. So what this one does is that it measures the free oil and the solid concentration. Here with this technology, you can get to know your concentration of your oil that is present in the water. Also, you can get to know the solid concentration as well as the oil droplet sizes and the solid particle sizes that are present in that water. So also, like I've mentioned, size distribution, you can get the size distribution of the particles that are present. And with all this information, when you know the particles that are present, when you know the type of solid that are present in the water, you can use that information to make an informed decision, probably in your phase of designing the type of treatment you want to give to your water. Okay? So also this one too is a low maintenance technology, no moving parts, no reagents, but it can also work, in a high pressure and high temperature environment. It is designed to work in a zone 1 area. All right. So the last one is free oil and solid just go back. So the ultrasonic method which also you can also get your free oil and the solid measured. Then you can get to, measure from 100 to 10,000 ppm. You can get on from between the ranges of 100 to 10,000 ppm of, particles, either the oil droplet size that are present, in the water. This one as well also is a low maintenance technology, no moving parts, no reagent. It can also work under a high temperature and high pressure. Disposal injection well and enhanced oil recovery injection well monitoring. So this technology can be used for injection purposes. You want to monitor the produced water, the quality of the produced water. You can use this technology as well. If you want to do well bore cleaning, we can use this to monitor the quality of the water, that is being, that is coming out from the well at that point. All right, let's go to the last one. All right, so this is one of our technology as well. Let me just quickly talk about this before I wrap up. All right, so an example of our fluorescence in action. So in the image, as you can see there, in the image, a fiber optic cable carries a light blue color. A cuvette full of water with a dye is put into it and is exposed to the blue light. As you can see there, when it is exposed to the blue light, the dye absorbs the blue light and fluoresces the green light. Then the monitor will now detect how much of the green light is generated. And, with calibration, it will indicate the oil concentration. This will only give you the oil concentration. This is one of our technology. This is just a portable one. This one cannot be used on the field. This one can be used, it's a portable technology that can just be carried but you can get your results right away, just, at the tap of my finger like this. Then also the next one is a particle characterization. I've mentioned it. Let's go to the next slide, please. Next slide. All right, so this is the process imaging. This is how it works. So the process imaging just captures, it can take different pictures of the water, of the fluid that is passing. Like I've mentioned, all this will be plugged, to a sampling point, and it will take the image of the water, the fluid that is passing. Then it will analyze the particles that are in the water, and it will give you the results in real time. All these are plugged online and to give you the results in real time. All right, let's go ahead. Okay, so this is the ultrasonic probe. So the ultrasonic probe emits a high frequency signal from the tip. So any oil or solid will reflect sound, so which is dictated by the sound transducer in the probe. So the monitor indicates how much sound it has returned. So it uses that to capture the particles, be it the oil droplet size, be it the oil or the solid that are present in the water. All right. Lastly, so let's go to the last slide, please. All right, so what are the finding solution? So like I've mentioned, for total oil, you can use our UV fluorescence, which is continuous. Then acidification plus solvent in the samples, surfactant in the samples as well. Then for free oil, for your free oil, you can use particle imaging, which is, we call it, it was previously known as Viper, and now it is known as process imaging, NIES 1A. So it can be used for this purpose as well, and like I've mentioned, you will get your results in real time. Then also, you can use, use our ultrasonic technology, as well as the UV fluorescence sample, technologies, which uses no acid before solvent in the sample. Then lastly, we have the emulsified oil. So to conclude, with the operators having the right measurement technology and understanding what the measurement is indicating, when we have the right measurement technology and you know what the technology is indicating, the operators will know how to best optimize their system's performance. Some of our technologies that can be used to optimize your equipment. Probably you're having a downtime or one equipment is down, you are feeling there's an issue somewhere. You can use our technology to optimize some of the technology that is being used to manage this produced water. All right. Thank you very much. So I don't know if you have any question. Okay,
Thank you very much. I'm particulate about this processed water. I'm particulate about that. I have a special interest in that because I want to know if it can solve our problem in Niger Delta. Lack of water. Water shortage, the impurities, water contamination. I want to know. So, the reason why I'm asking this is to know what is the end point of these technologies. I feel we have usage of the endpoint of this technology upstream, where you talk about injection that is used during the drilling and the rest, or oil exploration. That is upstream. Coming downstream, what is the benefit, the end product of these technologies? When you are done with analyzing our water, checking and testing, can the common man drink this water? What is the end point? What is the value to the common man? Thank you.
So thank you very much for that question. So like it has been said by other speakers, what this technology does actually is just to help you to get data, to understand the particles, the oil, the concentration of the oil that are present. So when you have those information, you'll be able to design the kind of treatment that will be, that can match up with whatever you want to use it for. Just like we have mentioned, for those that do reinjection, the kind of treatment they will prefer or that they want to go for will be different for those that want to dispose. And for those that want to, for those that want to use it for irrigation and for other purposes, which has been mentioned by other speakers. All this, what this technology will only do is just to give you the analysis, the particles, the data, that when you have those information, you will be confident to just, okay, now that I know that this is the type of solid, I have green algae in my water, I have so much sand, I have this type of metal in my water. You can now go ahead and provide the right solution. Instead of just saying, okay, I have this water, let me just do this treatment. But when you have the information, you'll be able to go ahead and provide the right solution. So like you have mentioned, so like we have asked, this will only give you the data, the analysis, and from there you can provide the right solution for the water treatment. Any other question, please? Okay, all right. Thank you very much.
Thank you. So that concludes the programming for today. I wanted to actually just briefly touch on that last question, though. I think one of the exciting things that's happening around the globe in that space is right now we don't have a way to take this produced water and make it into drinking water for the common man. That's not a technology that's available now, but that is a focus. And the reason I say it that way is because I think a large part of this process is an education of the consumer in the sense that, I'll talk about in America. In America, we have very large-scale waste treatment plants that take in things like human waste and all the other things that you can think of that come down in the rain and get flushed into the gutters and come into these systems. And those systems are then, or the water within those systems is then repurposed into drinking water and things that people are in fact using. And when you talk about taking that sort of waste and turning it into drinking water, and then when you talk about taking the oil and gas produced water that we're talking about today and bringing it to drinking water, a lot of it I think it's a mental hang-up of, okay, well, I know what this water comes from. I know what it is. I'm used to drinking that, so that's okay. This is a totally new resource. I don't know what it is. I don't know what's in it. And so I think part of it is understanding what's in the water, understanding what those contaminants are. And the reason I say it that way is because there are absolutely field tests that will prove out that the water that is being produced out of these oil and gas wells, once it's through some of these processes that we've talked about today, it is absolutely cleaner than the stuff that we are in fact drinking. And so I think part of it is just the simple education of the common man, as you use that phrase, and I think that's a fantastic phrase. But I think the other side of that is, in terms of large-scale operations, we're not at the place where we can do this at a large scale yet, but that's what we're building. That's hopefully what some of these conversations today are going to lead to. So I really appreciate the question. But with that, I want to recognize everyone. Thank you again for being here today. I believe we're going to be wrapping up for the day. I know we're a little bit early, but thank you so much for your time and attention.
Elvis? Where's Elvis? Where?
Help me to tell her. I am tired.
You can't have them. Just introduce her. I would need to. Yeah, just get the information. Okay. Yeah. Sorry. Can you call them on the Just give me my laptop. Give me my laptop. Sorry, one of you guys should call. Don't worry, when I introduce you, you can tell us the topic. And then you then introduce other panelists. That's fine.
What about the girl that did it? Maybe their profile is there. Just read it now.
No, not all of them. The last two, I couldn't put them up yet. They came in late.
I think this is the topic. I'm going to forward it to you. Is that okay?
So when I call you, you just introduce the topic, and then you want me to call the other panelists myself? But I don't have a profile. I couldn't have, it was late. Yeah. So when you go up,
I should read it. That's going to be stressful for me. To bring everybody's profile. Sarah, after you close the profile, or you go to the profile for a while. You understand, right? Okay, you want to be considered from last? So let's see how this goes. Let's see.
WhatsApp me. Okay, and then send your information there. Okay, and then I'll make sure I'll tell you about producer associate. And we have a booth out here. So after this panel ends, I think I'll be in a panel. We can talk more and out there. Okay. Yeah. Yeah. Thank you.
So, Raj, you want me to ask you? I'm taking your one now. Writing your question. I was going to ask you about.
I'm coming. He's filling me in, so I don't
Yeah,
like
so,
any
so
information.
this is the profile for the other presenters. You're not going to talk about it. I can use your laptop. I can use my laptop.
So you might want to ask, like, how is the U.S. companies or the U.S. oil and gas operations addressing this issue out there, right? And I can relate that to overall operation. You can start with that because the technology comes after that. Okay. We need to tell people why technology is important and where it will help in sustainability. But before that, we need to.
So the first question is how does US address produced water?
Yeah.
And the second question is what technologies do you recommended technologies to help?
It goes this 1, 2. She's going to come last as the moderator. Use my laptop. Take. Just stick now.
You have to tell. I'm much more comfortable.
He's still coming up. Just use my laptop.
So Fatima,
This is the first person.
This is the first. Sorry, hold on a second.
First, when you're done, just click X off. Please keep on touching this when you say the system doesn't sleep. Then this next. This next.
This anybody here, right?
Yeah. This next. This next. She's supposed to be the last person because we'll have another profile. But her name is Fatima. So I'll drop Fatima on the group right now. So just go ahead.
So that's why it's coming on the group.
Yeah.
Where's the file for Fatima's on this tab?
Fatima is yeah.
Is it moving around, shopping around with this?
No, you need to do that.
All right, ladies and gentlemen, good afternoon. Welcome back to this session. So we'll be having a panel session in a bit. I hope we are ready. Are we ready? Are we ready? Are we ready? All right, so those of us at the back, can we come forward, please? So let's know we're together. Please, those at the back row, could you come forward? It looks a bit scanty on this side. All right, ladies and gentlemen, we'll call up the panelists at this point. So first of all, I want you to, can we all just rise up on our feet for like a minute? Let's stretch, if you don't mind. Just stand up, just stretch, talk to the person beside you, get to know them, just for a minute. You can stretch your legs, you can walk to the person. If you see anyone you don't know, you want to, Joshua, you can walk up to her and ask what's her name. You know, just find out something, and then we'll get seated in the beat. All right, if you're 30 more seconds to do that. Please feel very free. All right, you can take your seat. So, ladies and gentlemen, we have the first panelist. I'm just going to read up her bio, and then she comes up. And please, we're going to welcome them with a very warm round of applause. Is that all right? We'll do this together. So first off, we have Dr. Miss Sarah Atedobi Nwini. I hope I got that right. She's an outstanding educator, a researcher, and a youth development coach with over 2 decades of experience in training, research, and consultancy. She has a PhD in sustainable treatment of oil-contaminated waste, oil-based mud, OBM, drill cuttings from Robert Gordon University in Aberdeen, UK. And she has an MNC with distinction in instrumental analytic sciences, oil field chemicals from RGU, Aberdeen, UK. And she also has a bachelor's degree in industrial chemistry from the University of Port Harcourt, Nigeria. Dr. Sarah is a chartered chemist with the Institute of Chartered Chemists of Nigeria. She's a fellow of the Chemical Society of Nigeria and the coordinator, Women in Chemistry. Chemical Society, Women in Chemistry, Chemical Society of Nigeria, Delta State Chapter. She's a member of several professional bodies. She's published several papers and made presentations at high-level conferences within and outside Nigeria. Her hard work has not gone unnoticed as she received several nominations to serve on the board of some key organizations in the oil and gas industry in Nigeria. She's a diversity and inclusion enthusiast. She led the team that won the first ever D&I Champion of the Year award by the Society of Petroleum Engineers International, Richardson, Texas, in the United States of America in the year 2022. She has been working in the Petroleum Training Institute, EFURUN, in Delta State for over 2 decades with several meritorious awards and commendations to her credit. She was the first to be appointed as a head research coordinating unit in the Directorate of Research and Development and the first to be appointed as a head of linkages, exchanges, and partnerships in the Office of the Principal and Chief Executive of the Institute, where she currently serves. Dr. Sarah is a devout Christian with love for humanity, environment, and biodiversity. She serves as a speaker at Christian events and programs. She is happily married. Ladies and gentlemen, please help me welcome Dr. Sarah Nwini as she comes up. Welcome, ma'am. Thank you very much. So we have our next panelist. So the next up we have Dr. Engineer Vincent Agilo. He's the president and GCEO of Ajivin Group, a visionary leader in petroleum, oil and gas, and maritime industries. With a first-class honors in petroleum engineering from the University of Ibadan and further training from Harvard Business School. He pioneers sustainable solutions while driving innovation in global energy and maritime projects. He's a current certified engineer and fellow of IOGRHS. You know, I don't know what that means, actually. Dr. Agilo has influenced industry advancements through major offshore and onshore projects. Beyond his technical impact, he uplifts communities through the Light Global Foundation, providing healthcare, skill training, and economic empowerment, solidifying his legacy as a leader in engineering and social development. Ladies and gentlemen, Dr. Engineer Vincent Agilo. A round of applause for him, please. So we'll call up our next panelist. Okay, we're calling up our next panelist. We're calling up Rajendra Gimeri. Let's welcome him, please, as he comes up. Dr. Rajendra is a visionary leader in water, energy, chemicals, and sustainability. As a director of business development for produced water at Badwater Alchemy, he drives global initiatives in the energy sector, advocating for a shift from linear to circular water management. With an executive MBA from UCLA Anderson, a PhD in physical organic chemistry, and a master's in pharmaceutical science, Raj blends technical expertise with strategic leadership. His work spans industry transformation, sustainable innovation, and business growth. Beyond his executive roles, Raj is a key contributor to the Produced Water Society and SPE Water Lifecycle Management. He advises multiple organizations and mentors NSF ICOPS cohorts, shaping the future of water reuse and sustainable energy solutions. Ladies and gentlemen, Dr. Raj, a round of applause for him, please. All right, the next one we have the next panelist. Ladies and gentlemen, with a round of applause, help me welcome Dr. Fatima as she comes up. We'll read her profile right now. All right, can we have Dr. Fatima's bio up, please? A round of applause for her. All right, Dr. Fatima B. Mohammed, PhD. She's a business consultant, championing climate solutions, energy sector partnership. She's a speaker. She's in government relations. She's passionate about sustainable growth and innovative strategies. Ladies and gentlemen, Dr. Fatima B. Mohammed. Thank you so much, ma'am, for coming. All right, so right about now, we would welcome the very last person that will coordinate this for us. Okay? So I think okay. All right. So let's have that. So to put this all together, we have someone who is very exceptional in what she does. She's one of the finest in this room this afternoon. She's a lot and much more. Ladies and gentlemen, help me welcome, to hold this all together, Ms. Joy Osiamehe. Let's put our hands together for her. She's a governance and sustainability specialist with over a decade of experience in ESG-aligned projects, policy and risk management in the environmental and energy transition space. As a curator of the Global Sustainable Energy Education and Leadership, that's GSEL conference, and founder of African Scholars Care Initiative, ASCI, she drives global collaboration on climate governance and education reform. With an MBA, MSc, and a doctorate in business administration in progress, she brings expertise in project delivery, stakeholder engagement, and policy implementation. A Prince 2 practitioner and certified Scrum Masters, she integrates ESG principles into governance frameworks to advance sustainable finance, climate adoption, and resilient economic growth in emerging markets. Ladies and gentlemen, to hold this all together for us is Ms. Joy. A round of applause for her. So I think we have all that mic. Could you keep this?
Thank you. Standing on existing protocols, my panelists have been executively ushered in today, so we will just be diving straight into our topic for today. So, like you know, we're just going to be talking about produced water, and this panel is going to just be centered on managing produced water for the energy sector in Nigeria. What are sustainable ways of managing produced water? So we have seasoned people here that have got the experience on how the upstream system works, and then we We will have them enlightening us today. And if you want to be mentored by them, feel free to rush to them after now so that they can give you some of their expertise and tell you how to get into the industry. Okay, Dr. V, I'll be starting with you. Basically, from an operational perspective, how do you describe the management of produced water currently in Nigeria? You need to give us like a clear description so that people that don't understand how it works, the extraction and the refinement of crude oil, just give us the flow on how it works based on your experience and expertise. Thank you very much.
Thank you, Joy, for the question. Good afternoon, everyone. My name is Vincent Agilo, and produced water, okay, I'll just go to the basics, fundamentals of oil and gas. So usually you have your oil, gas stored in a rock called reservoir. We call it reservoir in engineering, petroleum engineering. Usually it's down the head. It can be in the water, it can be, but it's in the rock, basically. So usually when you drill, so it's expected for you to have some sand, water, then oil, and depending on some assets has what we call associated gas. Some assets are free of gas, and some assets we have non-associated gases. So basically, when you drill from the subsurface to the surface, so you need to separate these three main elements: oil, water, and gas. So what we are talking about today is the water. So remember, in geology, oil is produced or has been formed for many years, over 500 million years ago. So that means the oil and water has been together for many years. So there's a bit of separation that is required. The earlier workshop you had was when someone was explaining how you test the quality of the water that has been separated. So in Nigeria, there's a law called environmental gas, NUPRC has a law or a regulation called EGASPIN. That's environmental guideline and standards for petroleum, oil and gas industry, for petroleum industry. So that guideline advised that for produced water, you need to treat it to what we call less than 10 ppm. Depending on your location, some location less than 3 ppm. ppm is parts per million. And because of environmental issues, you cannot discharge that water at your area of operation, except you operate at a location that is 20 nautical miles from the coastline, and you have a water depth of 200 feet. So if you operate in any location other than these, you need to treat the water to less than 10 ppm, and then transfer it offshore to an approved location that meets this requirement for discharge. Alternatively, what you can do is to reinject the water back to the reservoir. So that means you have to drill another well, which is very expensive. For a land operation, a well is about $10 million. For a shallow well operation, a well is about $40 million. For offshore, you talk about $100 million, $500 million. So what we do in Nigeria, some of the old wells that are no longer producing crude can be reused as reinjection. So reinject the treated produced water after carrying out what we call reservoir compatibility studies. So you need to check the reservoir and check the compatibility of the reservoir with the produced water. Otherwise, that will affect your future crude oil production. So these are the methods we use in oil and gas at the moment. You reinject the water. Alternatively, you batch the water, or you shuttle the water through vessels from your production platform to offshore location that is approved by NUPRC. Thank you.
Thank you so much, Dr. Vincent, for that. At least he has given us a good background to kick off for today. And thank you for enlightening us about the NUPRC laws and how the whole fragmentation of how the process goes. It's quite insightful. And moving on, standing on that, we would move to Dr. Sarah. Dr. Sarah, the whole essence of this is looking at the environmental, social, and governance impact of what produced water, if not managed properly in Nigeria, would give. So we want to move over to you now to give us some analytics on community impact. Let's know what and how, when not managed properly, how it has impacted. Give us both the negative and positives anyway.
Okay.
Thank you.
Good afternoon, ladies and gentlemen. I'm particularly happy to be sitting here to discuss this because this is a major issue. And basically, in the sustainability chart, before you can say something is sustainable, it has to be environmentally friendly, socially acceptable, and economically viable. So even in the treatment regimes and the things that we are trying to do, we must check it in the sustainability chart. I'm from the Niger Delta, to be precise, Bonny. I still miss my grandfather. And I watch Natural Geographic a lot. And I wonder why they don't come to Nigeria to do any of those their documentaries. If my grandfather were to be alive, I'll make sure I bring Natural Geographic to my community. I saw all sorts of seafoods that I don't see again today growing up as a child. There's one they call, I think it's called mussel meat in other tribes, but in my language they call it elongene. It's a beautiful seafood. And the kind of fishes that when he is a fisherman, when he goes for fishing, he comes back with different species of fish, beautiful colors. Sometimes when you look at these fishes, you don't want to eat them because they just look so aesthetically beautiful. The issue is that, fine, oil and gas production gives us prosperity as a nation. But when we don't operate it sustainably, the destruction it brings to the environment is incredible. And many times, the measurements and the statistics we get are not correct. Because these are not, you don't go down to the grassroots where the people live. You see the shoreline disappearing. Our mangroves are no longer what it used to be. I thank God for the United Nations monitoring and their initiative to remediate the Ogoni land. And I'm telling you, it's going to take a long while. What we're seeing is just the shoreline, but we really don't know in totality what is happening in the groundwater. Now, my community in Bonny is purely marine. But my village, if you drill a borehole, you get very, very classic, pure fresh water. People come from other communities to drink that water. But as I speak with you today, that water is no longer what it used to be. So the impact on communities, I'm using my own case study, not something I read up somewhere, is tremendous. And we haven't even talked about the impact on the health of the people, their lifespan, life expectancy. I remember growing up, when I go to the village, you see their skin so beautiful. And I'm wondering, they don't even have access to some of the things that we use in the city. And you see them, they eat fresh food, but it is no longer the same. So the impact of, I don't want to say irresponsible, unsustainable business across all sectors, the impact on the environment is incredible. And I want to say that we need to begin to have sustainability behind our minds. Let's bring in sustainability into the curriculum. So when people are growing up, they understand sustainability. If you bring any project to me, you bring any concept to me, first thing that goes on my mind is this sustainable?
Thank you very much, Dr. Sarah. Thank you so much for giving us this impact analysis. Thank you for talking about the mangrove restoration. Thank you for mentioning the effect about the UN deployment and all resolutions at the last COP29. I will tell you for free that in the NCCC, that's the Nigerian Council for Climate Change, they are really working very hard on the mangrove restoration in the south region of Nigeria. And I can tell you that our DG is full-blown on it. So yeah, we would get solutions in the Niger Delta. Haven't had the community impact and what he's done in especially regions of the Niger Delta from her personal experience. She will still give us more in terms of data reference. We'll be moving over to Raj. Raj has been in the industry for God knows since I was a baby, yeah, so for over 20 years. And we will want to really talk more on how we've learned how the Nigerian companies run this process on crude oil separation. We've heard about the impacts. Now we'll be talking about how the U.S. companies, because these are our big brothers, we look up to them. So we want to see how do they address sustainable practices for produced water. Over to you, Raj.
Thank you. Thank you, Zoe. I want to piggyback on what Dr. Sarah said, that to implement sustainable strategies, you have to have a sustainability strategy first, right? So first of all, don't believe what you read in the news. You might think that the oil and gas company in the United States don't care about our environment. That's completely not true. And I'll tell you why. Because in the US, most of the oil and gas industry, whether it's upstream, downstream, or midstream, and including the produced water industry, everybody is focused about, just like Dr. Sarah said, providing the best possible cost-effective energy to everybody in the world and in an environmentally friendly way, right? Taking care of our water, taking care of our air, having a healthy biodiversity. So how do you achieve that? So first of all, you need to have a sustainability strategy. What should that include? Most of the produced water companies today in the US, first of all, they do their baseline studies. What does that mean? The baseline study includes their overall operational carbon footprint. It includes their solid and liquid waste footprint, right? It includes their energy footprint, because without knowing what your baseline data is, you cannot make any more improvement, right? So that's the basic fundamental things that pretty much every oil and gas company and produced water company is doing today. And after you have your baseline, then they look into it and say, okay, where are the areas that we can make improvement to reduce our carbon footprint, to reduce our emission, to reduce our water waste, so that we can be more water positive or even water neutral, so that we are not using more water for our process, but maybe whatever water we are using, we are recycling it, so we can be at least water neutral, right? But you need to have that first. Once you have the data to implement that, then we go into the technology section. The operational efficiency part. How do you achieve operational efficiency? Once you have the data, then you have to look into your overall operational procedure and process. Okay, if you are a treatment company, what type of treatment technologies you are using it? How much of energy does it consume? What type of pumps you are using it? What type of water analyzers and sensors and monitors you are using it, right? And then are there better technologies available that can supplement that? So that is the second phase, you go into that. And on top of that, the next phase would be, are there any disruptive technologies? Is there a cost-benefit analysis? So let's say we built a plant, it costs $20 million, right? But if I invest today, I have the capital to put another, which is a lot more energy efficient technology, but it's cost $40 million. Are we willing to take that capital risk to see the long-term benefit, not only for the industry, but also for the community? So it's happening in a stage-wise process. It does not come out as ESG. It comes out more as operational efficiency and energy efficiency, but it is the same thing happening, and it's happening in every level. I hope I answered your questions.
Thank you so much, Raj, for that. It was a very holistic picture, starting from the carbon footprint, explaining data interpretation and how investment runs, the operational efficiencies. Yes, and that will lead us into investments, because that's one very exact thing you touched on. Investments in this, will I say, the recycling of the water, of produced water. So it takes me to my final panelist. Yeah, so Dr. Fatima. Yeah, we're going to be talking about what are like innovative strategies what are the innovative strategies we can actually use to achieve investment in terms of funding. He touched a lot on the scope of investment, what's going to be the ROI, is there going to be return on investment, is it going to be sustainable, why should people, invest in produced water, and how do we get people to understand that there's a gap, and then if you invest in it, it would give the right dividends, and also, yeah. over to you on investment strategies for.
Okay. Good afternoon, everyone. So I feel like I have two questions in there. We have the innovative side and the investment side. How we're going to get money for, like how we're going to get funding. A lot of times, people always miss out the part of, okay, you want to get funding for a particular project. First things first, people don't look at crowdfunding and venture capitalists, and also partnership as well. So I'm going to elaborate on these things. For crowdfunding, you can start with, so I belong to a network called Women in Energy Network. The N.I.E.S is seated in the crowd. And what people don't know is that when you're looking for funds, you can tap into your network. That's crowdfunding. Crowdfunding doesn't mean that you have to go to the website and go and start getting funds. Before we move into partnering with the government and doing PPP with other people, we can first start with looking in our network and looking at our family and friends, or looking at other networks that we join to get these funds. Then we can now move into partnership. And you need to know this. If you're collecting data, if you're doing water, sustainability, anything that you're doing, you need to do research and you need to create innovative things. For example, you can use the Internet of Things, get data that you're going to use to collect real-time data that you're going to use to create a report to request for these funds. Some people need funds and they don't really have data. They don't have a report. People are not seeing their ROI. If I don't see my ROI as a business person, I'm not going to invest. I'm very sorry. So if you're doing partnership, please do your work. Show me the beginning and the end. Begin with the end in mind. Let me know how much I'm going to get. So you can do crowdfunding. Crowdfunding can start with join a network and connect and see how you can leverage that network and get funds from there. If you can't do that, then you now look for VCs. In Nigeria, we have a lot of hidden venture capitalists. I don't want to mention names because I don't want to promote any brand here. I'm here to discuss this. But we have a lot of venture capitalists that you can leverage from in Nigeria before you get to the banks. I think a lot of people need to make the banks the last resort for when you're looking for funding for a particular project. You have to look inward first. And if you know you're in the energy sector, of course we are here. There are networks that you can join. I always recommend Women in Energy Network because you have like minds of people. You have people that have done the job. So you are shadowing people that have done it. People have 25, 30 years of experience and you're just joining. Trust me, you're cutting off all your stress. They're going to handhold you and say, oh, you can get funding from here. You can get funding from there. That's before we go to the government. So if you want to go through the government, there's you can buy, there's something called, I don't want to start going deep into capital market kind of things, but you can buy commercial paper. And you can invest in it, and you can get money out of it and say, oh, this is what I'm putting as my collateral. You'll be putting that as a collateral to the bank to get money.
Thank you very much,
Yeah,
Dr.
so it
Fatima.
depends.
Thank you so
Thank
much
you.
for the insights.
I hope I
today
answered
on
your
how
question.
we will get funding to address produced water, the risk. This would now be taking us into other aspects. Over to you now, Dr. Sarah. Dr. Sarah is the Assistant Director for Training. She's the Head of Leakages and Exchange and Partnerships in the Petroleum Training Institute. So we'll be talking about, because we've talked about funding, we've talked about carbon footprint, we've talked about data, we've talked about the downsides to what the impact is in community. We need to look into the risk. You know, it's still an extension of what the impact is. What are the key risks for improper disposure of produced water? A key risk, we've talked about, you know, you've touched this before, but it would be good if we can add some data reference into it. And then also, because of the PTI experience, give us some treatment solution that you think that we can use to address this issue. Thank you very much.
Okay, thank you so much. I'll go back to sustainability again, because if you want to treat, whatever treatment regime or strategy or technology you want to apply, ensure that it's sustainable. Now, if I'm going to be spending $100,000 on electricity to treat a waste sample, is it economically viable? It's not. What you want in treating some of these wastes, and when you talk about produced water, most times you only talk about the oil. There are other things in that water that are highly detrimental to health. And key on the list is what we call heavy metals, the likes of cadmium, nickel, lead. These are very toxic metals that if found at a certain concentration in the human body, is going to kill, it's going to be detrimental. And the other contaminants the other contaminants you find inside the produced water can be treated. But heavy metal, you can't really treat directly. What happens to it that it bioaccumulates, and the fishes eat it, or let's even start with the planktons and zooplanktons, and the food chain goes, and it continues and is now magnified in human systems. So to answer your question, as an environmentalist, I want to project biological methods of treatment. Let's use biological method of treatment. And there's one that is clearly known. We have biosurfactants that you can use to reduce the oil on cotton, so render that solution innocuous to the environment and put it back in the water in a way that it will not affect the aquatic life, especially. So I want to project biological, like what you're doing with the mangroves. You're planting, basically. So that's a biological way of treating. If you have rats in your house and you bring a cat in, of course, they will deal with the rats for you. There's no chemical. You're not doing anything. And I see they use it in Israel, where they bring in, there's this farm. Somebody had a farm where they had these rodents plaguing the farm. And what the person did, they just got some owls, these daytime owls. And the owls are very sensitive. They can detect the movement of a rodent, even if it's underground. So I want to project, as an environmentalist and as an advocate for environmental regimes, I want to project that we use biological methods of treatment. Because if you want to use the technological ones all the time, you're going to spend electricity. And you may even generate, let's say if you're treating drill cuttings, if you're using the thermal disruption method, you're going to generate ash. There'll still be another emission coming out again. So why don't we just use biosurfactant, do a soil washing, render it innocuous to the environment, and put it back there? So that's my own projection. Thank you.
Sarah, thank you so much, Dr. Sarah. That's really, really, you spoke from the heart. And it's good that we're talking about biological ways to address, like to mitigate the impact of environmental degradation caused by produced water. Thank you for that. I'm not going sequentially, but I will go over to Raj. Just because of the flow of conversation. She has talked about biological ways to mitigate the impact. We would like you to touch on some technological ways that we can address the ESG needs on produced waters. So over to you, Raj. Thank you.
Thank you, Zoe, and thank you, Dr. Sarah. I mean, when it comes to selecting the best technologies, of course, we all agree that we want to select the best available technologies that are the most sustainable, right? So you have to choose the best of the worst, right? So depending upon what's available today and depending upon where you are, let's say if we are talking about United States, the produced water out there, have a very high TDS, anywhere from 150 to 180,000 TDS, right? Biological treatments are available out there, but most of them, just like Dr. Sarah said, they are mostly used for pre-treatment and also for treating, we call bacteria, SRB, APB, so the pathogens and things like that. Maybe a little bit of iron reduction and things like that. But the overall, if we want to use produced water for beneficial reuse, when I say beneficial reuse, either for irrigation purpose, agricultural purpose, other fit for application purpose, such as generating hydrogen, using for cooling tower for data centers, they all need different quality treatment. So we'll have to pick the technology that's available today and have to work on new technologies for tomorrow, which are better, more energy efficient, right, are cheaper. But if we pick some of those today, if you look into the technology selection, you will have to either pick a membrane-based technology or a thermal desal-based technology. And there are several of them, so I'm not going to pick which one you choose because all of them have a little bit different flavor. But I do want to come back into the questions of sustainability and having clean water, clean air for the community, having a good aquatic life, having a good biodiversity. So just so you know, everybody, in the United States today, there is a lot of study going on treating produced water to the very high level, to the drinking water quality. The technologies is available today. Cost is a different issue, right? I mean, we are ready to pay $5 for this bottle of water at the airport. We don't pay that much anywhere else, right? So it all depends upon where you are and what the need is. But cost is a little bit high, but the technology is available today in the United States to do that. But we are very worried about the liability to the personal hygiene of our community and also of our aquatic life and biodiversity. So there is a lot of study going on 700 plus analytes in the water, not only the metals, the non-metals, the VOCs, right? The radioactive materials. Most of those are not even listed in the regulatory guidelines. Only around 450 are listed in the EPA, Environmental Protection Agency. The oil and gas industry is expanding up to 700 analytes and analyzing it to see what is the level of treatment needed, how much are they left when we treat the water, and also how does treated water impacts the irrigation. If we use for a certain crops, how does the soil behaves with treated produced water? Does it still maintain the same minerals, right? How does the soil growth impact? It's not only the hygiene of the human being and the aquatic life, but also the environment. So there is a lot of study going on, and we care about the environment, we care about clean water, clean air, our community. So there is a lot of study going on, and there is technology available. Are they cost effective? Can we do it cheaply today? It all depends upon how desperate we are for water and which location we are out there. So.
Thank you so much, Raj. But I would really like, for the sake of knowledge, it would be good for you to even mention some of the technological solutions that are on ground now, so people can continue with some level of research. Just mention one, two. We're not saying you're selling them, but it would just be good to just mention the technology. We can pick it up after now, but just mention for the sake of knowledge purpose, yeah.
So I think it was in the presentation before. Any water treatment goes into several levels, right? Primary, secondary, tertiary treatment. So if you are looking into produced water, you start with pretty much just like doctor out here said about separating oil, water, and gas, right? So there is a three-phase separation going on. From there on, then there's the oil and water separation. So you have to make sure that most of your hydrocarbon is separated from the water. So there are different separation technologies involved. Once again, I'm not going to pick, but we have companies like Produce Water Solution out here. If you go and talk to them, they will give you several solutions on the oil-water separation. Then we have solid separation, suspended solid, sand separation. So there are desanded de-oiler technology. And then you go beyond that, there is desalination technology, membrane-based thermal desalination. You go beyond that, there is membrane-based technology, ultrafiltration, microfiltration, right? And then you generate solid. So there is solid management technology. There's a long list.
Thank you, Raj. A round of applause for Raj. Thank you so much, Raj. So it's more about the separation techniques and the technology innovation we've gathered in separation techniques for water purification and all that. So yeah, thank you so much, Raj. And I'll be going over to Dr. Fatima. Dr. Fatima, do you want to talk about, we are still on innovation, so the innovation around produced water, because it's water coming back to society, so we're looking at purification, how does it not so what are possible innovations that we can bring on board? They've talked about biological, you've talked about technological, you can still add to that. And if you want to still put some light into the funding conversation that you talked about earlier, then over to you.
Thank you so much. So I'm going to be brief on this one, and I'm still going to go with, when it comes to innovation and technology, I will still say AI is your best friend. I can see a lot of Gen Zs here. Or are you Gen Z? I've been looking at you since. Is there any other Gen Z apart from me? Yeah, because I know a lot of you guys use a lot of AI. You know, you use ChatGPT and everything. You can actually put that in water sustainability. People don't know the amount of data. Like when you buy like an AI sensor, an Internet of Things, so there's this stuff called AI sensor you can use to just check like I don't know how to explain it, but it's just a mini sensor that you put to check if the water is good for you, or if you can use it, or if you can reuse it or not. Whether you like it or not, we human beings, we don't have that full information. AI can do everything for us. AI can give us real-time data that we can make use of. And also in terms of funding, so there's a sustainability funding, like a green sustainability funding that you can get these funds from. And I always advise, as I said, please make sure you have the right data. You don't want to go and ask for funds when you don't have these data right. So please, you need to make sure that you have the right data. But in terms of technology, please, AI is your best friend. I'm pro AI to get the right information and to look at it. Lifetime AI, so Internet of Things, you can research it as well to get real-time information to do your work. So over to you. Thank you so much.
Much, Dr. Fatima. Thank you. I don't know. I think the mic takes 2 seconds to pick. Okay, now I would come over to Dr. Vincent. I think everybody here is doctor. Wow. Okay, now Dr. Vincent, because being operational in the Nigerian space within the EMP system, I just wanted you to touch on gaps. I want us to talk about the gaps, and then if you've got any policy recommendation that could address these gaps in the process of,
All right, thank you so much. Wonderful speech from my honorable panelists. So basically, for the oil and gas, I think the NUPRC and NMDPRA are doing a fantastic job, because we need to look at a solution that fits to our environment, practically speaking. Like Raj said, America, there's a lot of support with funding. There's a lot of interest in sustainability. I think we are not there yet in Nigeria. Everybody wants to get the oil out of the subsurface. We want to ensure that we are cost effective in our approach. So that said, basically, for me, I think we have a lot of policies on ground. Implementation is what we need. At the moment, NUPRC charge every oil and gas company who discharge water offshore. If you want to discharge water within the locations that are not approved, that they charge for that. I think it's about 50 cents per barrel, right? Try to enforce compliance, basically, just like a penalty to every discharge you do. So we need to ensure that we enforce companies to go for the appropriate disposal method, or either you discharge offshore or you inject into the wells. I know it's very expensive, but we need to consider sustainability. We need to consider the environment. And the other bit is also putting system on the vessels that go to discharge this water. How are you sure that in the course of their transition, they arrive to the appropriate location for discharge, right? So there are no systems in place to check and monitor the process of discharge. So the essence of the whole game is not just to spend money, it's achieving the purpose of ESG, environmental friendly manner in discharging and treating produced water. Of course, monitoring as well in terms of the treatment. For us as Ajivin Group, we have a system that uses ceramic membrane to treat produced water to less than 1 ppm. We work with a partner in Norway to achieve this. And this has been approved in Nigeria. So we are trying as much as possible to ensure we encourage environmental sustainability, as well as ensuring that produced water is properly monitored. There's an IT, you can check the performance of this system right on your phone. You can monitor the progress of this system. And it's very interesting, no chemicals involved. No chemicals involved. Thank you.
Thank you so much. So we will just thank you for all the insights. You even touched on something that's very that I found very interesting in terms of the haulage, the vessels moving this water to their location. How sure are we? So I wouldn't want us to spend so much time on the panel. These whole issues on climate action and environmental sustainability, ESG, is all born from the Paris Agreement in 2015. And with the emergence of Trump now saying that ESG is, it's not important, it's not useful, there's been some level of pushbacks, and you see all the all the banks pulling out of net zero alliances and all of that, do you think that it causes a threat or it in any way affects the let's say reuse or reintegration of this water back into our ecosystem? Does it have any challenge for our regional climate? I'm not talking from the global perspective now, because what the West is 200 years ahead of us. So we're not in the same pace. We're not operating on the same pace. But with all the sustainability challenges we are having globally right now, where the world is, does it have any effect or impact to our topic for today on produced water? So I would start with you, Dr. Sarah, and in that way, everybody will be giving me their final words. Thank you.
Thank you very much. ESG is a good thing, but the thing is, once there's a policy, once a policy comes up, you have to be careful to be focused on the agenda of that policy. We all know that the ESG began to get into some other things that now kind of, made it a little bit political. Today, one of the things we have benefited from ESG is the fact that there is more gender involvement in certain industries, to the point that if you have a board and there are no females on that board, you won't get funding. So ESG is a good thing. And part of sustainability, there's an aspect of sustainability that is not in the original chart, which has those three aspects I mentioned, and that's the political side. You can see how the emergence of Trump changed the entire dynamics, meaning nothing is static, nothing is permanent, things change. Definitely the only aspect I see where it will be affecting produce water management is just funding, that's all. Apart from funding, I don't think the idea of managing the environment, climate action, it's not really a bad thing. I've told you my experience from my own community and how it has changed.
Thank
so
you very
much,
Dr.
The only challenge I
Sarah,
see is just funding. Thank
you. A round
you.
of applause for Dr. Sarah, please. Over to you, Dr. V. America being our big brother and telling us sustainability is a scam. What do you have to say about that, and how does it affect the impact? No, Dr. Vincent, I just want to go, yeah. So just how does it impact sustainability, especially on the reuse of produced water?
Okay, for us in the oil and gas, industry, safety is number one. Environmental friendly manner is one of our key approach. And of course, in our business, the local law supersedes international law, okay? So the NUPRC regulation supersedes whatever is being said in America or in Europe. And of course, I do not think Trump is also saying don't treat your produced water. I'm not sure that is his policy. Right, so treatment must be done, must be managed properly, and then ensure that the environment is good. So I would just encourage our EMP partners as well as the regulators to ensure that our environment is safe and the produced water is properly managed. Thank you.
Round of applause for Dr. V. Raj. I know you're very eager to answer this question, but I would like to tweak the question a bit at this junction. I want to talk about compliance gap in our systems. What advice do you have? If you have listened to the panels, you will hear that the policies are in place, but we have a gap in, it's not about writing the laws or creating the act, the PIA Act. It's about how do you ensure that there's actual compliance of these policies that have been created. So there is a gap in governance. So you're coming from an expatriate point of view to give us an advice on what you think should be done to enhance accountability for governance and compliance. Thank you, Raj. Over to you.
First of all, I don't know if I'm the right person to answer that question, but I will tell you, it all starts with the culture, right? Because we all are, every country is culturally different. Some have a little bit more democratic process. Most claim they do, but the rule of law, right? Access to information, And then, of course, accountability, just like I said, and responsibility. Those are all handled differently. But I think this is where community and having awareness within the community and asking for data from all level of government, not only government, both at the state, depending upon how it's distributed out here from the higher level to the local level, asking information as a citizen of every country, we have the right to ask for the government because we pay taxes. If you pay taxes, right? Once you have that information, asking the right questions to your elected body. And I think community can play a major role. Maybe the advocacy group here as well plays a role as well. Bringing some of those information to the public. This is where media and communication people, reporter can play a major role. Highlighting some of those gaps with real data.
As accountable, that's about it. Now over to you, Dr. Fatima. We are still, I know you've answered a lot of questions on funding, but the dynamics has changed right now. We are talking about accountability metrics on how to ensure that the laws that are being put together, like if you can see about the NMDPRA talked about 3% of oil and gas companies going into CSR, you know, all these laws are there. I think in section 3 of that PIA Act, we've got something on CSR, and then the model is ESG. And so there's a lot of laws and laws and laws. And Dr. Vincent has said earlier that it's the local law always supersedes. And that's why I like the fact that Nigeria is taking a front seat in the energy space. And I also wish and hope that we will also take a front seat in the energy transition space. But my question to you is, how can we, from a local perspective now, ensure that these laws are not just written in paper? How can they, and that's your final words they're going to. Thank you.
Okay, so I think this mic is, as you said, 2 seconds. Piggyback for what Dr. Raj has already said. It's just us holding our leaders accountable. When you read these laws and they are implementing these laws, you have to make sure you hold them accountable to these laws. Because whether you like it or not, he has already said it, the local law supersedes any other law. We are in Nigeria. So I would not be thinking about what Trump is doing in his own country. I'm in my own country, so I have to focus on that. So I think it's us holding them accountable and also doing things right. Also having the right regulations as well. A lot of people just want to cut corners because they are business owners. The who know who mentality needs to stop. If you don't have a regulatory document, please get it. And if NUPRC and NMDPRA has a process or a price that you need to pay, please pay it. You know, because these regulators are there to help you. You are the reason why they are there. So at the end of the day, you have to make sure that you comply as well. Because we always attack the regulators, but we don't attack ourselves sometimes. Because we also need to look inward and make sure we have the right documents in order to help these regulators as well. So that's what I'll be closing out with. Thank you.
Thank you so much, Dr. Fatima. A round of applause for Dr. Fatima. And we'll have to be closing the curtain here. We have talked on policy recommendations for sustainable produced water management. We've talked about industry commitment to us, and then we'll be talking about...
So usually when we do that, a lot of professors from the universities, consultants are gathered. There's a multidisciplinary team from different departments that goes into that study. So that is the first assessment that is done through the process of any execution of any project in the oil and gas industry. So that already factored in some of the concerns you have. However, like I said earlier, we need to monitor. We need to ensure that disposal is done properly. Thank you.
V, a round of applause for Dr. V. Thank you so much. Thank you so much for trying to, and I would like to add to Dr. V. We've talked about community holding government accountable. Because when we touched on this panel, we talked about compliance. So it's very important that as a community, we do some aggregation within ourselves and then see how we can hold our legislators accountable. It can work. If it has worked in other countries, it will work in our regional climate. So let's keep the faith alive and then learn to hold our governance, our government or government representatives accountable for our issues within the community. One comment? No more questions for my panelists? One comment? I'm taking it. So I did one here, that one there, and then.
Yeah, so good afternoon.
Good afternoon,
Yeah,
Dr. V.
Thank you. So my name is Dr. Victor Nwachuku. I'm an environmental social development specialist, and I worked in the international development space, and I just wanted to throw one or two things. Things we look at when we're approaching projects like this from an environmental perspective. One thing, yes, we're talking about risks and impacts, but before you start talking about risks and impacts, you need to identify them. From the federal part, the Federal Ministry of Environment has the Environmental Procedures and Guidelines 2021. It's important that companies are conversant with that. The kind of operations that fall into different categories. In Nigeria, we have category 1, 2, 3. Most oil and gas sector activities would usually fall under category 1, meaning that you would require an environmental social assessment. Now, it's important that your activities are screened, especially activities which will lead to the production of produced water, for instance. What does N.I.E.S screening do? N.I.E.S screening environmental risks. It's also important to remember that there are social risks. In the world today, you can't separate environment and social. There are environmental impacts, there are social impacts. So in these communities, you need to understand that especially in the local communities or underserved communities, they might have limited water resources, natural water resources. If produced water is contaminating natural waters, then you're limiting access to water, meaning that people who use water from rivers or streams for their livelihoods might not be able to use them. Another thing you also need to consider is labor influx. So say a company like Dr. Vincent's company is coming into a community. Obviously, he's coming in with personnel. He's not using, or he might not be using personnel from the local community. Labor influx is very important in the international community. Why? So you're bringing in workforce. There could be issues of gender-based violence. These things also need to be taken into consideration because they also increase the social risks. And then the final thing I'd like to say is ecosystem services. Ecosystem services are important. It has different ecosystem services. There are different ecosystem services in the north, different in the south. But like in the south, where most of these extraction activities are done, you need to look at the forests, you need to look at aquatic life, and then what will be the impact of produced water on these. So at the end of the day, the mitigation measures, which most of them would be technological, will help solve these things. But everything starts from having your environmental assessment done, because it will guide you on the N.I.E.S risks and then how to mitigate. Thank you.
A resounding round of applause for him again. Thank you so much. That was talking from a professional lens. He gave an holistic view of the different measures in the north and in the south. I'm sure everybody heard it, so I don't have to give a recap of what he had said. So anyway, thank you so much. It's been a very insightful panel. Raise your hand if you learned a thing or two today. And please, after our family photo, I would like you to grab a mentor. You see, Women in Energy, hold them. Petroleum Institute is the PTI. Hold her. You know, she can help you transition into the energy space. And if there are any gaps you want to know, see, he's very operational from the local perspective. Dr. Vincent to guide you. You can talk to Raj if you want to get the international view of things and then see how, because we use that for monitoring to see if are we meeting up to this, are we meeting, because obviously they are standards. Anyway, so we've come to the end of this session and I hope it was worth a while to spend an hour with us today. Thank you so much for listening.
A round of applause for the panelists, please. So while getting ready for the photograph, I want to extend my gratitude to all our speakers and for everyone who came here. And for the speakers, thank you for those invaluable insights. And to all the participants, I want to invite you for another engagement next year. So the knowledge shared today is pivotal as we strive for sustainable and efficient practices within the oil and gas industry. So as we draw the curtains to the Nigeria International Energy Summit 2025, it's evident that our collective discussions have significantly contributed to shaping the future of energy in our nation. The exchange ideas and spirited debates have not only highlighted the challenges we face, but also have illuminated the pathways to innovative solutions. I encourage each of you to carry forward the momentum from this summit into your respective fields, fostering collaboration on implementing the strategies we've explored together. Our commitment to energy security, sustainable practices, and financial viability remains paramount as we navigate the evolving global energy landscape. Thank you once again for your dedication and your contributions. As the light dims, the curtains close, Elvis is about to leave the building. So we'll see you next year, the 2026 NIES. My name is Elvis Nekusagba, and I'm out of the building. God bless.
Please, let's come down from the podium for a quick photograph. Please, Dr. Victor.
No, down.
Down. A lot of people came here earlier saying they are here for networking. I believe this is the opportunity you have to collect some people's numbers, exchange contacts, and of course, that can open up a lot of doors for you. I hope you get back to where you are coming from safely. Thank you very much for coming.